Alright, so in today's video, I'm going to be going over the hyperbolic and inverse hyperbolic derivatives. So first off, what is a hyperbolic function? Well, they're very similar to the trig functions, and you can probably notice that from the name. This is hyperbolic sine, hyperbolic cosine, hyperbolic tangent, hyperbolic cosecant, hyperbolic secant, hyperbolic cotangent. And that little h, it's sine h, cos h. They can be referred to as sinh, cos, tanh, cos. I would say hyperbolic cosecant. Sec. I would say hyperbolic secant and hyperbolic cotangent. You can say either way. Um, Basically, they're like the trig functions, but they're defined using exponential functions. So similar to with normal trig functions, the hyperbolic tangent is hyperbolic sine over hyperbolic cosine. And you can see a similar pattern for hyperbolic cosecant, hyperbolic secant, hyperbolic cotangent. So let's take a look at the graphs of the hyperbolic functions. Alright, so these are the graphs of the hyperbolic functions. It's not the main focus of the video, but I think it's probably good to see. So if you want to, you can pause the video and take a look at them. But now we're going to move on to the derivatives of the hyperbolic functions. Alright, so for sinh and cos, I'm going to actually use the definitions of those functions to find the derivatives. And then for all the other ones, I'll just show them. So the derivative of sinh, we know that sinh is e to the x minus e to the negative x over 2. And this is actually a derivative we're able to find. So I'm going to split this up into, well, the derivative of e to the x is just e to the x. So this is 1/2 e to the x minus 1/2. So what's the derivative of e to the negative x? So this is actually a chain rule, because our inside function, instead of being x, is negative x. So we know that the derivative of e to the x is just e to the x. Instead of having e to the x here, we're actually going to have e to the negative x, because that's our inside function. And according to the chain rule, we need to multiply by the derivative of the inside on the outside. So the derivative of negative x is -1. So these negatives will cancel. And then we can write this as e to the x plus e to the negative x over 2. And if you'll notice, that is actually hyperbolic cosine. So this is cos of x. So it's pretty neat how that works out. Now, for the derivative of cos of x, this is the derivative of e to the x plus e to the negative x over 2. So, similarly, this is going to be 1/2 the derivative of e to the x plus 1/2 the derivative of e to the negative x. So this is going to be 1/2 e to the x. And then the derivative of e to the negative x, that's negative e to the negative x, as we saw previously. So we're going to have a minus 1/2 e to the negative x. So this becomes e to the x minus e to the negative x over 2. And that's the definition for a hyperbolic sine. So sinh of x. So it's similar how sine, cosine, they differentiate to each other, except for the derivative of cosine is minus sine, where here the derivative of the hyperbolic cosine is just normal sine. So it's similar but not identical. Alright, so here is all of the hyperbolic derivatives. As you can see, it's very, very similar to the derivatives of the normal trig functions. But here's something I'd like to point out. So, as I said before, the derivative of hyperbolic cosine is just normal hyperbolic sine. And another difference is the derivative of hyperbolic secant is negative hyperbolic secant times hyperbolic tangent. So the derivative of secant of x is secant x times tangent x. And if you notice here, we have a minus where we wouldn't with the normal secant. Alright, so here's a way that you can kind of remember which ones will be positive and which ones will be negative. So your kind of main three trig functions, which would be sine, cosine, and tangent, the hyperbolic versions of those are the ones with the positive derivative. Meanwhile, the other three, which is secant, cosecant, and cotangent, the hyperbolic ones of those have negative derivatives. Alright, so let's do some practice with these hyperbolic derivatives. So for this first one, we know that the derivative of hyperbolic secant is negative hyperbolic secant times hyperbolic tangent. So we actually need to use our chain rule here, because our outside function, we can call that f, is hyperbolic secant, and our inside function, we can call that g, is 2x squared. So, according to our chain rule, this is going to be f prime of g multiplied by g prime. So f prime, we know, is going to be negative hyperbolic secant times hyperbolic tangent, but instead of evaluating at x, we're evaluating at 2x squared. Alright, and then on the outside, we know the derivative of 2x squared, that is 4x. So our final derivative is negative 4x times hyperbolic secant of 2x squared times hyperbolic tangent of 2x squared. Alright, for this next problem, we need to use two separate derivatives. So we know that the derivative of hyperbolic sine is cosine, or hyperbolic cosine. So we know this first term is going to be hyperbolic cosine of 5x, but then we need to multiply by the derivative of the inside. Alright, for this second term, our outside function is actually x squared. So let's call that f. F is x squared. And then our g, which is our inside function, we can call that hyperbolic cosine. So our chain rule tells us that this is going to be, so what's the derivative of the outside function? Well, our outside function is x squared, so our derivative of that would be 2 times x, but instead of x, we're evaluating at cosine hyperbolic, or hyperbolic cosine. Alright, so now we need to multiply by the derivative of the inside. So what's the derivative of hyperbolic cosine? That is hyperbolic sine. So our final derivative is cosh of 5x minus 2 cosh of x sinh of x. Alright, so what's the derivative of tangent hyperbolic of e to the x, or hyperbolic tangent of e to the x? We know our outside function is hyperbolic tangent, and our inside function is e to the x. So the derivative of the hyperbolic tangent is hyperbolic secant squared. So sec squared, and then we evaluate at the inside, multiply by the derivative of the inside, which is e to the x. So our final derivative is e to the x times hyperbolic secant squared of e to the x. Alright, now for our inverse hyperbolic functions. So to help show what they look like, I included some graphs, just so you can see. Alright, so here are the derivatives of the inverse hyperbolic functions. So hopefully with the hyperbolic derivatives and the inverse hyperbolic derivatives, you don't have to memorize them, because they're a bit harder to memorize, in my opinion, than just the normal 6 trig functions. But if you do, there are some nice patterns, but it is a lot to memorize. So, alright, now let's do some practice. Alright, the derivative of the hyperbolic cosine inverse of 4x minus 13. So we know that from our previous page, the derivative of the hyperbolic cosine inverse is 1 over the square root of x squared minus 1, but we're evaluating that at the inside. So our inside function is 4x minus 13 squared, and then we have minus 1. multiplied by the derivative of the inside. So the derivative of 4x minus 13 is just 4. So our final derivative is 4 over the square root of 4x minus 13 squared minus 1. Alright, now what's the derivative of the hyperbolic cotangent? Well, that is 1 over 1 minus x squared. I'd just like to note that the hyperbolic tangent and hyperbolic cotangent have the same derivative, but they do have different domains. If you were looking at the picture, the hyperbolic tangent is only from -1 to 1. Meanwhile, the hyperbolic cotangent is everything else. But that's not really usually a focus in a calc class, so don't worry about it too much. So our derivative of hyperbolic cotangent is 1 over 1 minus x squared. But instead of evaluating that at x, we're evaluating at the inside, which is x squared minus 6x plus 5, whole thing squared. Now, what's the derivative of the inside? So the derivative of x squared is 2x, and the derivative of minus 6x is -6, and the constant differentiates to 0. Our final derivative is 2x minus 6 over 1 minus x squared minus 6x plus 5, and then that is squared. Alright, so the derivative of the hyperbolic tangent inverse of sine of x. So our outside function is this, which is hyperbolic tangent inverse, and our inside function is sine of x. So what's the derivative of our outside function? The derivative of hyperbolic tangent inverse is 1 over 1 minus x squared, but we are evaluating that at the inside, so that's sine of x, so sine squared. And then what's the derivative of sine? That's just cosine. So this is cosine of x over, now 1 minus sine squared of x, using a Pythagorean identity, that's equivalent to cosine squared of x. So cosine of x over cosine squared, that's just 1 over cosine of x, and that's equivalent to secant of x. Alright, thank you for watching. I hope that you found the video helpful. In the next video, I'm going to be going over some higher order derivatives, and after that, I think I'll do some more differentiation techniques, and eventually we'll move into some applications of differentiation. So I hope that you have a good day, and thank you for watching once again.